sub d, meaning the average of the differences. So what is it? It's equal to 3 minus 2 plus 4 minus 1 plus 5 plus 2 minus 0 minus 5 plus 3 minus 4. And if you calculate that out, as long as I did this right here,
It's 5.
it's 5 exactly. So it's 5 divided by 10. Remember, because this is an average. And what's 5 divided by 10? Plus 0.5. So that's X bar. Okay? Also have to calculate S. And I calculated S, and it's equal to, I'm gonna find it somewhere. I'm gonna look at something first. What I'll do is I'm going to go over to the two sample tests in dependent samples comparing independent and dependent. Yes, S sub D. So it's 3.48. See on page 392 in the box 11-9. It says T is equal to D bar divided by S sub D divided by the square root of n. That's the test statistic. Okay, we haven't gotten it yet, but that's what the test statistic is going to be. And so what do you have to know in order to calculate the test statistic? You have to know D bar. D bar is the average difference. All I did over here was I called it X bar sub D. It's the same thing. D bar is equal to X bar sub D. I like X bar sub D because we know it's a sample mean and it's a mean of the differences. This says it's also a sample difference, but my presentation, I think I like better than their presentation, but these two are the same thing. The D bar is equal to X bar sub D. And so that's that. And then this is S sub D. So what you have to do is you have to be able to calculate the sample standard deviation from that data set. And I'm telling you that that data set is equal to a standard deviation of 3.48. Okay, so make sure you know how to calculate the sample standard deviation because it comes into play. And so, I don't think we need anything else to calculate for this hypothesis test because this is the third step. What's the fourth step? The fourth step in the hypothesis test is what? The test statistic. Okay? How do you know if you have a Z or a T? You go to the decision tree. What's the first question? Is the population normal? And this, in this case, it's the population of differences. Does it say anything about here the population of differences being normal? No. What's the next? So you go to the left. Next question.
30 or more.
Is it 30 or more? No.
No.
So you end up in the left box, meaning we don't get to that in stat 2. So you go back to the top, and I have to tell you, assume normal differences. And anytime I say to you, as a hint, assume normal differences, you have to know it's a matched paired difference test. So I'll write up here, assume normal differences. So, back to the decision tree, assume normal differences, you go to the, and the answer is yes, you go to the right. Is that right?
Mhm.
Yep. Next question.
Standard deviation.
Is sigma known? Nope.
No.
And it says
Use T.
T distribution. And it just so happens that the T test statistic is on that page. And what does it say? It says T is equal to, what does it say? So D
X
bar,
bar D.
D bar, but I have it as X bar sub D over S sub D. They use S sub D?
Yep.
All right, we both use S sub D, divided by the square root of n. And so what's X bar Sub D,
0.5.
it's 0.5 divided by 3.48 divided by the square root of 10. And so what's that equal to? That's equal to minus, no, I'm sorry, 0.45. And so when you do this calculation out, T 0.45, test statistic. And then what's the fifth step in the hypothesis test? Formulate the decision rule. Is this a Z or a T?
T.
This is a T. Is this a one or a two-tailed test?
What? One tail.
It's a one tail. Which tail?
To the
To the right. This is accept HO. Reject HO. Accept H1. And then, what's the critical value? Go to the table. Which column are we in? We're in the 0.05 column for a one-tailed test. And then the question is, how many degrees of freedom do we have?
9.
And we have n minus 1 degrees of freedom, which is 9 degrees of freedom. And so this is a plus test statistic. And so with 9 degrees of freedom, alpha 0.05 in a one-tailed test, what's the critical value?
1.833.
1.833. So if the test statistic T is less than plus 1.833, then accept HO. If not, reject HO and accept H1. So, where's the test statistic? Oh, it's way over here, 045. Oh, 45. What region is it in?
Except.
Accept HO. So, 6, accept HO. What is HO? That mu sub n is less than or equal to mu sub d, so mu sub e. And so, what were we testing? We're testing is mu sub n greater than mu sub b. And because we've accepted mu sub n is less than or equal to mu sub b, then what? No,
It's not better.
mu sub n is not greater than mu sub b, so it's not better. Everybody follow along with that? Okay? So, when I do a hypothesis test, as you've seen, every single time I write all 6 steps down. I write the decision rule every single time. Because as I'm writing it, that's another reason. When you see my homework that I send back to you, most of it's like handwritten. Okay, and the reason why I do that is because when I do it, it makes me think, even though I know what I'm doing, it makes me think as I go from one step to the other. And as I go from one step to the other, I'm already thinking about what the answer is going to be. Because I have some idea, even before I do it, what the answer is going to be, because I'm spending time as I go from one step to the next. And so ultimately here, if you get in the habit of doing things this way, you won't go wrong, because it's a pretty mechanical, straightforward test. And so if you write down and graph, that's the other thing. I always graph these things. Most students don't. And it's fine most of the time. What happens is that when you don't graph it, you don't know if this is a plus or a minus sometimes, this critical value. You know, if all of a sudden it's over here, and you have it on the left at minus 1.833, what would you be doing? Well, in this case, you'd be doing the same thing. But sometimes what happens is that it lies in the rejection region, But if you have the rejection region on the wrong side, or if you're always calculating positive test statistics, when in fact it should be negative, then every now and then you're going to come up with the wrong answer. Completely incorrect, because you're going to be on the wrong side of the decision rule. And so therefore I tell students, look, write down the 6 steps. You don't take much time. Get it to be much more mechanical. And so therefore, when you write these things down and you do it the correct way, it's a lot easier to understand as to whether or not you've said true or false to the actual claim of the hypothesis. Okay, and so as you'll see in the homework that I sent back to you, what I find is that a lot of times, well, number one, I see a setup like this. It would be, is the gas better or greater than? And so what I see is this from a student. I see H sub O, H sub 1, I see mu is greater than 10, because that was, we were doing last week, it was, is mu greater than or equal to some number? And then I see over here, mu is equal to 10. And I say, no. What happened to less than? Where is less than in this test? And so you had to have it there. There it is. Now it's less than or equal to. That's the complete test. And so I was very picky when it came to these kinds of things, because I'm trying to say to myself, what would they have said if they accepted HO? I don't know what they would have said in the end, because they have it as equal to. But in fact, no, it could be equal to or less than. So when you set up HO and H1, make sure it's set up in one of the ways that's on that first page of the handout. It's got to be equal to versus not equal to, less than or equal to versus greater than or equal to versus less than. It has to be, it can only be one of those 3 different ways. That's it. It can't be anything else. And then secondarily, make sure that you're testing whatever it is that we're asking about here. And so if we're saying better than, sometimes, in this case, it's going to be greater than, because we're talking about mileage. If we were talking about taking a pill, and whether and how long it takes to react on you, what would better be if we were measuring minutes till you feel better? Better would be less minutes. Okay, so make sure when you read the question you understand what the test is. Sometimes better might be less minutes. Sometimes it might be more mileage. Sometimes I'm going to say it's going to be very straightforward. I'll say, is it greater than? And you'll say, oh, I know what greater than means. That's greater than. Sometimes I'll say at least. What does at least mean? At least means greater than or equal to. That's what at least means. So make sure you understand the terms and what each one of these equalities mean. Or if I say, is it different? Now the means different. What's different? Not equal to. That's different. Okay, so make sure you set that up correctly. Make sure you have the decision rule. Obviously you have to make sure you do the test statistics correctly. Z, T, use the decision tree. That decision tree will never get you in the wrong place. And then critical values. That's why they call them critical, because they separate the the rejection region from the acceptance region. All right, so when you do your hypothesis test, be deliberate, be slow, be accurate, and you'll never have a problem with doing. And then, once again, like I said, you have to know how to calculate S, the sample standard deviation. Everybody knows how to calculate a mean. Everybody should know how to calculate a sample standard deviation. This is statistics 2. Sample standard deviation was in like chapter 3, I think.
Page 84, I think.
Huh?
I think it's page 84.
There you go, page 84, she thinks. So, and she's never gotten it right. No. So, make sure you understand how to do the calculations and everything else that's related to it. Okay, so if I look at chapter 11, we've gone through it, and so therefore, the only thing we have left is chapter 12, part of chapter 12, part of chapter 13. And those will be next class. Okay? Okay, so that's it. And that's it.